Hey, good morning, everybody, and welcome to our webinar this morning around FactoryTalk Logix Echo. My name is Scott Peters, and I'm a sales manager here in Northeastern Ohio. Just want to remind everybody that this webinar will be recorded, and later this week it'll be placed out on our YouTube channel for your viewing at your leisure. Anyways, at this time, I'm going to turn it over to Mike Schott, who is one of our product specialist, and he'll be leading our webinar today. Mike?
Hey, thanks, Scott. Hi, everyone. Thanks for joining us today. Like Scott said, I am Mike Schott. Here, let me turn my camera on so you can see what I look like. I'm out of the Erie Rexel office, formerly the Winkle Electric office, and I'm going to be here. We're going to talk about FactoryTalk Logix Echo. We're going to dive right in here. Today, I want to talk about just kind of what is FactoryTalk Logix Echo. What is it and how does it work? We're going to talk over the basic features of it, do a little overview of the dashboard, which is like the main user interface for Logix Echo. I'll do a quick demo just to kind of show you what I'm talking about, and then we'll talk about some more of the features of it. I'm going to compare it to Studio 5000 Logix emulator, because that was the older emulator. Logix Echo is now the new modern emulator. So there's some similarities to it, but there's also some new features that Logix Echo is moving forward with that we'll talk about. Then we'll go into kind of a deeper dive, talk about some technical parts of it, and some advanced features that really make Logix Echo take off as far as value to the end user there. Then hopefully we'll wrap it up, kind of make it all, have it all make sense to you guys, and how FactoryTalk Logix Echo can help you. How it can give you value in what you're doing, how it can make your life easier, maybe as an engineer, and then take some questions there at the end, or throughout the presentation. If you have any questions, just let me know. All right, so what is FactoryTalk Logix Echo? It is, in very general terms, software you put on a Windows environment that will emulate a Logix controller, and it allows the execution of PLC code and gives interactions with other software. And so, like I said, it's similar to the Logix emulator that was out there before. It's got a lot of new features and things that make it a lot easier to use. So you can use Studio 5000 to download your project into the emulator, similar to Logix emulator, but it'll be a little more streamlined. And it's going to allow interactions with other software, like HMI software and simulation software, third-party applications, and stuff like that. Right now, it can emulate 5580 ControlLogix PLC. Before anyone drops off, hoping it would support the compact Logix that is coming. So future releases will support 5380 compact Logix controllers and the Guard Logix controllers as well. So hey, hang out with us today if you're hoping for compact Logix support, and take a look at all the features Echo has, so that when the support for those controllers does come, you'll be able to take off running with it. It supports version 33 and up, firmware versions 33 and up. It came out about the same time version 33 was, so it's going to support all those versions moving forward. And this I took right out of the release notes. Rockwell tested it and gave their blessing to install on Windows 10 Professional 64-bit. And then if you wanted it on a server machine, Windows Server 2016 standard 64-bit or later. So FactoryTalk Logix Echo is software, and it's sold as a subscription software license only. So that means you would pay a yearly fee for the license and support. There's two levels of support. There's the 8 to 5 support that gives phone support, access to the knowledge base, and product updates, software updates. Then you can jump up to the higher level of support if you like, the 24/7 that gives you additional hours of call-in support. But that's how the license is being sold. And one license will enable a single instance that supports 17 controllers in an emulated chassis. So, the graphic I have shown here that's a 17 slot chassis, and you can put theoretically a controller in each slot. Okay. And each controller could be running its own program. The controllers can interact with each other. That front Ethernet port can be emulated, and we'll get into all that here later in the demo. So you could have 17 controllers running at the same time in your emulator. Now, having said that, I'm going to pull up the first kind of technical slide here. There are some system resources you do need to keep in mind if you're installing this on a machine. Mainly pay attention to the resources per controller instance. So you'll need some logical cores for the OS and the Echo application, but then you'll also need one per controller instance. So if you have 17 controllers in there, you're going to need to make sure you've got 17 logical cores for just the controller instances. And then there is a per controller memory allotment as well. So if you're going to scale it up to 17 slots, just make sure you have enough system resources. And I did learn the hard way that if you don't have all that there, it's not going to work. So pay attention to that. All right, so I'm going to talk about some basic features, and these are some features that you did not find in Logix Emulate. So this kind of makes Logix Echo a lot cleaner and easier to use. The one that I like the best is you use the same project file that you would put into your physical controller. So if anyone remembers Logix Emulate, you had to go and manipulate your ACD file, change the controller type before you could put it into Logix Emulate. So this one, you don't need to change anything with your ACD file. It goes right into Logix Echo. And then you can finish your testing in Logix Echo and then turn around and dump the same file into a physical controller. So that makes it a lot cleaner and easier to use, definitely. I talked a little bit before about the controllers that are supported. So we have the ControlLogix 5580 controllers. This is the list of controllers that are supported now. Again, future releases will be the GuardLogix 5580, CompactLogix 5380, and Compact GuardLogix 5380 as well. One thing that kind of caught my eye, the P controllers are available here. So it's interesting. If you wanted to test out some of the Plant PAX 5.0 process objects and see how they execute without buying one of those P controllers, that's a cool function that might help you out. Virtual SD cards, and all the L8 controllers are sold with an SD card slot, and that is supported in Logix Echo. When you spin up a controller in your emulator, there will be by default a virtual SD card attached to it, and it's a directory in Windows, but it gives you the same functionality you would have if you were connected to a physical controller with an SD card in it. Like I said, that front Ethernet port of each controller can be emulated, and I'll show in my demo kind of what that means and how to do that. So you can have an IP address on each controller if you like. If Logix Echo can communicate with HMI software, all of Rockwell's HMI software, so including View Designer, which Logix Emulate did not have. You can even connect to third-party HMI software as long as it's using SIP class 3 messaging. And like I said, there's a dashboard that you can kind of, as the user interface for Logix Echo. Obviously, you'll be able to create and add emulated controllers from there. You could actually bring in an ACD file you already had, and it'll look into that ACD file and create a controller that matches what's in your file. And then you can even download a project directly from Echo without opening Studio 5000. And I'll kind of show that in my demo real quick too. Another kind of feature of Logix Echo, you can do snapshots. So if you have one or more controllers open and maybe you have a program in each one and maybe they're interacting with each other, you could take a snapshot of all of those together or just one of them, but a snapshot of all together, and it'll save that, that controller state, controller time, tag data, execution context, and you can save it as a single file, and then bring it back in and restore it later and take off right where you were left off before. So FactoryTalk Logix Echo is kind of like the platform, and then to update controllers, because controllers are going to come out with future firmware updates, you would maintain those by just downloading an emulated firmware update from the PCDC on Rockwell Automation, their website. So it would be very similar to maintaining firmwares and with physical controllers. When a new firmware version is released, you just download the file and install it into Echo. And then you have the option of using that new firmware. Last item on this slide, there's a built-in API. There's actually two APIs built in that allow third-party simulation software integration, and that's going to be a big part of the value add of Logix Echo, and we're going to dig into that a little more later because that plays a big role in it. Okay, so I'm going to do a quick demo here. Kind of want to show what it looks like before we start talking more about it. So this is the dashboard that I've been talking about. Pretty clean. It's pretty clean, minimalistic. There's various panels on it, and I'm going to kind of start over here in the devices panel. And what I'm going to do is I'm going to add a controller from ACD, and this is that function I talked about where you can Echo will look into your ACD file and create a controller based on what you have in there. So I have my Echo demo here. I'm going to open my ACD file, and it kind of looked in there, saw it was revision 34. It put the name of the controller in here. You'll see anytime you add a controller, it's going to be added as an controller ControlLogix 5580 emulator type, and there's an IP address you can give it. I'm going to leave it here. This is that Windows loopback IP address, and we're going to change that later, but I'm just going to add it as it is right now. So you see that controller ends up here in our devices slot. Let me close these tabs here. I can actually double click on it, and it'll bring up the information for that controller in this general tab. A lot of the same stuff we saw when we set it up, and there's an on-off button. You can turn the controller instance on and off if you don't want it to be available. This is that SD card, which is by default attached. So there's a directory in Windows generated to store those files. And again, we picked our ACD path, so that's already loaded in there. If I want to come over to the right side here, there's a device status window that can open up, and we can expand it. And this is just that run mode switch that we can change the run mode of it. And again, we can turn it on and off from here if we like the controller instance. So I'm going to do a download, actually. So I'm down here in the bottom left corner. There's a download button. We have our ACD file picked up, and we can actually do a download right from this Echo dashboard. So I'm going to click my download. Here's our progress bar, and I'm actually going to looking for my output window. Here's my output window. So this is going to show me what's going on. My download has started, and while that's downloading, I'm going to go ahead and add another controller manually, and you'll see I can give it a name. This will go in slot 1. I can pick a revision. We have 33 and 34. Just for fun, I'll pick 33. and we can pick an IP address, and you'll see I have multiple IP addresses here, and I'll explain that in a minute. But I'm going to pick 116 on this one because we're going to use 115 later, and I'm going to add that. So now those two have been added. I'm going to open up my FactoryTalk Lynx network browser window and show you what these look like in Lynx. And so you'll see there's an emulate Ethernet driver that comes up, and we have our Windows loopback IP address, and we have the actual IP address I gave it in slot number 1 there. So we can see both of those controllers there. I can jump up to my Ethernet IP driver, and we'll only see the 116 controller. But what we can do, if you just have one of the controllers assigned with a real IP address, you can browse into that and across the backplane and still see all of the controllers in that chassis. So one way you might use this is assign a single IP address to one of the controllers, and users could go in and get to all of the other 16 controllers by just browsing across that backplane. So now what I'm going to do, I'm going to go ahead and jump back into here and go into slot 0 here, and I'm going to put this IP address onto this 115 IP address and apply it, and bring up our FactoryTalk Lynx network browser, and we ought to see that pop up here in our driver here, and it did. So one thing that you can do, and I just actually learned this now, I didn't realize you could give more than one IP address to an Ethernet adapter. And so the way I did that was I went into my Ethernet adapter properties, and if we go to this advanced button here, you can add multiple IP addresses, which I did. I already have them added in here to a single adapter, and that's how you would get multiple IP addresses for each controller. And so by doing that, I'm allowing myself to give a unique IP address to each controller in my Echo emulator. So we have 115 and we have 116 that we could get to through unique IP addresses. So I see I'm going to click on my download tab here. I see that it's been downloaded successfully. And if I come over to my run mode switch, I see it's not in run mode yet. I can put it into run from there. And I'll put it back to remote. Now we're kind of in remote run here. And so what I'm going to do now, I'm just going to quickly, this is my program that I downloaded in there, and I'll show you. You can even download from Studio 5000. It looks the same as if you were downloading to a physical controller. I have my path set up already, so we're not going through links or anything. And the download happens the same way. And you can see Echo over here. Echo is mimicking the run mode of this controller. And if we change it back to run mode, that will be reflected in Echo over here. So they are linked that way. And I have a View Designer application here, and it's just a simple application. I'm going to emulate it real quick while that's starting up over there. And I just have kind of a basic rung here, kind of like a motor start stop circuit with a run timer just to show some feedback. And I know, anyone who's ever developed an HMI application usually will have a controller that they're connected to as they develop that HMI application. Usually what you do is you go and you grab a controller off the shelf and you plug it in and set it on your desk. But nowadays, hardly anyone has those controllers left on their shelf anymore. So, using Logix Echo would be a reasonable alternative to that, if you don't have those spare controllers laying around anymore. And I don't know that I've ever developed an HMI application without having that active connection to a controller to test the interactions with it. So you'll see you'll see we have our, basic start. This is a start stop. You can start it, you can stop it. And what you might want to do is just, check your logic to make sure it, make sure it works and interacts properly. And that's, that's a very basic use of Logix Echo here. Similar to what you might have seen with Logix Emulate. Okay. Only this time, obviously Echo is compatible with View Designer, so that's a big plus. Okay. Any questions on the demo before I move forward?
Yeah, I got. If you're using a non-Rockwell HMI, is there a way to interface that into this emulator? Like, let's say I've got an Automation Direct HMI. Is there some way I can put that in here and make it work with the emulation program?
So yes, it's Logix Echo is compatible with third-party HMI softwares. I'll have to be honest with you, I'm not completely knowledgeable on like Automation Direct's HMI software, but as long as it's using SIP class 3 messaging, it will interact with it.
So I could download a tag name database from here. If I go File, Save As, you typically get 3 options, either the ACD or the one's a K, one's an X. Are those available coming out of Echo?
Yeah, I believe so. So we can. You mean, are you talking about if you save it from like Studio 5000?
Yeah. Like right now, if you go to File, Save As.
It's the same. This portion is very much the same as if you
right, so
you're connected to a physical.
Yeah. Okay.
Yeah.
Okay,
It's
perfect.
At this point, this end of it is there's no difference between a physical controller and emulate or I'm sorry, Logix Echo. So that's a nice part of it. Yes.
If I had the HMI sitting on my desk, as long as I knew the IP address, I could just plug it in an Ethernet port, or does it have to go through a switch? I know I'm probably asking a question that you haven't done yet.
I haven't tested it yet. As long as it's on the network, I don't see a problem with it being able to connect to Echo.
Okay.
As long as it can see it through that network, so once it is coming out of Echo, in that Ethernet driver, there is no difference between a physical and emulated controller. If your software can see it, on the network, it should be okay.
Okay.
The disclaimer is I haven't tested it with Automation Direct software, but the notes from Rockwell is that it supports third-party HMI softwares.
Okay, and did I just see a note pop up? It's version 33 and above only at this time, or at some point
right?
Be down to how low will we be able to go at some point?
I haven't heard any information about going lower than 33. Obviously, it'll be support 33 and up, but I don't believe it will support lower than 33 in the future.
Hey, Mike, this is Thad. Yeah, it's going to be 33 and above only.
Sure. Okay. Thanks, Thad. So I kind of mentioned comparisons between Logix Emulate and Logix Echo. So this is kind of just a comparison chart to show some things that are the same or different, and you can see that Logix Echo has some more supported things that Emulate does not. The 5580 controllers, the 5570 controllers are still supported in Logix Emulate. They are not supported in Logix Echo. Moving down the list here, just picking out some items of interest that I see. There's the virtual SD card, communications with View Designer, and here's that interface to non-Rockwell HMI software. You could kind of do it before with Logix Emulate using the DDE OPC topic, but in this case, it's more of a seamless integration. So motion instructions, it's still only going to support virtual axes only. There is a future feature coming on, and I think I talk about it in a later slide, so I'll wait till that comes up. Okay, getting into a little deeper dive here, just explaining a little more what you can do and what you can't do. I'm going to start over here on the you cannot. So you cannot connect to physical I/O devices, or cannot connect to real drives, access to real drives, produce consume tags with other physical controllers, and that's a theme. Logix Echo will not control external physical devices. So that's something to keep in mind. Where that's going to come into play is that API that I touched on earlier with a simulator, and we're going to get to that, I swear. So another thing that it can't do is emulate true redundancy. So it does support redundancy, but if you download your project, it'll always show behave as a primary with no partner. So really, you couldn't test that switch over between a redundant pair. Again, the motion support, you're gonna have to use virtual axes for motion applications, but there is a future feature, okay, called axis test mode that will enable simulation of real axes. I don't really know what that's going to look like, but we're definitely going to keep our eyes peeled for that future feature. That and along with the support for the other controllers. Produce consume tags with other emulators and message instructions. Again, you can communicate with other emulated controllers just fine, and other softwares, but no physical devices. You can connect from an HMI. The only thing it can't do is that HMI button control on the Panel V5000s. That's a class 1 message, so it does not support that at this time. There's going to be a couple slides here of just some lists of things. I'm not going to go over each one. I'm going to point out some points of interest. By all means, feel free to stop and look at and talk about one if you see something you want to talk about. But again, this top item, the emulated controller is restricted from establishing connections to physical devices. So, that was on purpose. It will not control physical devices. But the API that's built in can be used to simulate input and output values. So if you have a simulator, that's where that data exchange would happen. Okay. No email functionality. That USB port on the front is not emulated like the Ethernet port is. Again, motion support, virtual axes and consumed axes only. So keep that in mind. And we're all going to be watching for that test axis feature. Let's see what else. Time scaling through the API. And again, this is going to get into that simulation side of it. If you have a simulator, you can actually sync time up and speed up or slow down the execution through your simulator. Like I said, the HMI button controlled does not function. The GSV and SSV instructions are going to be emulated controller instances only. Okay, so I keep talking about the API. So here's a little background on what these APIs do. So Logix Echo comes with 2 sets of APIs built in. And what those APIs are going to do, they're going to expose parts of Echo to third-party software. So there's a service API, and it's going to expose all those controls on the dashboard that I showed you to third-party software or applications. So it's kind of an open interface. If you have a third party that or even if you want to write your own application, you can tie into that and do it from third parties. And then there's also controller API, and that's where you would have third-party applications come in and do things like control the execution of the controller, have access to your tag data, so you have that I/O tag data exchange, and even scale time, like I mentioned. So your simulation and your Echo instance would be time synced, and you can speed it up or slow it down based on what your settings are. And then with each of the Echo installations, there's a software developer kit that has pretty good documentation on how to access those APIs and how to get into those controls. So hopefully we're going to start bringing this all around and maybe give some scenarios of how this might help you. And I'm going to stop here, and I'm curious. I'm going to ask a question, and feel free to shout it out or do a hand raise or chat. Is there anybody here that hasn't heard the term digital twin? Where Logix Echo really gets its value, its power, is as part of a digital twin. And so we've all heard the term digital twin, and I came across a phrase that kind of made sense to me, and that's the coming together of the mechanical CAD and logical operation. And so I'll do a brief explanation again of digital twin in case you want to hear it described a different way or whatever. The digital twin would be you have your model of a machine or a part of a machine or a factory floor, your 3D model, and you simulate it. You add physical properties to it. You add motion parameters, and you make it a simulation. And then you have your logical controller, your control logic. And that's where the FactoryTalk Logix Echo comes in. And so those two will tie together. Okay. And then that creates your digital twin, where you could theoretically simulate, well, not theoretically, you can simulate a whole machine, or like I said, a factory floor or part of a machine. You can execute your code. You can see how the machine operates. You can do testing on it. You can do all kinds of things in that digital environment. And so where that's going to be beneficial, I'm sure you can come up with ideas. Everyone on this call can come up with ideas of how that would help them. But just to cover a couple bullet points here. If you're building a machine, you can test the entirety of the machine before it's even built. So now we're talking about finding bugs, catching errors. If your control strategy doesn't work with the physical part of the machine, you can identify that. You can rework it. You can redesign it so that you're not stuck in the field during the commissioning phase, and extending that delivery cycle. And I think we can all understand the benefits of that. Certainly one of the more stressful times for an engineer is when you're commissioning a machine and you realize it has to be reworked, and you don't know how long it's going to take. Another idea, it's going to create some better designs. So as you're designing a machine, you might design a machine with a safe design that works. You're not able to verify a new design until the machine is built, and that's a pretty big risk. So this way you would be able to verify a new design or maybe a more efficient way of doing it, and be able to show that and prove it that it works before you actually go and build the machine. Another interesting way, this is going to be beneficial, would be operator training. You could create a simulator, train your operators on a realistic, safe environment without putting equipment and production at risk. Instead of taking a brand new operator and sticking them on a production line, right away off the bat, you can give them a little bit of experience on a real environment without putting that risk out there. And again, if you have an existing production line or a factory floor or whatever, you can try out things with improved processes. Maybe you've always done something a certain way, but now you can test things without a risk. There's no downside to trying new things on a digital twin, because it's all a digital environment. You're not gonna smash a robot or take the plant down or anything like that. So this graphic is kind of like the big picture of a FactoryTalk Logix Echo. You see, I've got the Ethernet devices over here. Once you get an IP assigned to one or more of the controllers, it sits on your network just like a physical device would, and you're looking at integration with connections to all these other devices, and then you have that public interface, that API that I talked about, that really brings in the interface or the simulation side of it, to make it part of that digital twin. And you'll see emulate 3D. That's another term I'd be shocked if everyone on this call hasn't heard yet. But that's Rockwell's simulation software, and obviously you get the Rockwell integration into Logix Echo, to enable that digital twin. In addition to you can also bring in third-party simulation softwares. There's a little utility called Studio 5000 Simulation Interface, that can allow integration into some of those other third-party simulation softwares. Anything that supports the functional mockup interface, which is a standard interface for simulation models. Down here at the bottom, I do have a footnote to. There's a neat little video on YouTube to show how that Studio 5000 simulation interface works. And by all means, go to YouTube and search for emulate 3D. If you watch some of those videos, it'll really kind of bring it together what that digital twin can do. So, kind of as part of a digital twin, this would be like maybe a traditional timeline for the delivery schedule. You have your system design, mechanical design, and a control system design. Then you build the machine. You integrate it in, then you do your physical testing, and then you do some rework based on what you see, and then you do more testing and maybe more rework, and maybe you're in this cycle for some time. And again, this digital twin schedule, they're showing system design and mechanical design, control system design kind of overlapping, and then you do your virtual testing even before your fabrication. And the idea is there you work out all your bugs, you get a more solid design that's verified before you even build the machine, and you can kind of build that machine with more confidence. And you do your physical testing, and in a perfect world there'd be no rework, but maybe there is some rework, but it's reduced or far less risky than you would if you didn't have that complete virtual testing done. All right, so kind of to sum it all up here, Logix Echo as part of a digital twin is definitely going to speed up your design cycle, and hopefully I kind of explained that in a way that made sense to everyone else here, not just me. So you can do more commissioning before you build anything. Really, you have a permanent design. You're not doing as much rework. You can use, like I said, you can use Studio 5000 simulation interface to support other third-party co-simulation models. So there's a good good integration there. Another idea, you might be doing a remote testing and troubleshooting. Maybe you build your machine and you have your digital twin on your system, and your machine gets out in the field, and somebody says, hey, it's doing something kind of funny. You can actually spin up your model, your simulation, and your instance of Logix Echo, and kind of maybe do some troubleshooting to figure out what's going on without having to go on site, and then maybe implement a fix for it that you could feel more confident sending out there. And again, it's going to mitigate your risk of everything, really. Programming changes, existing equipment. You can test all of your changes in a safe environment. Test your output, verify it all, and probably sleep a little better at night at the end of the day. And then the operator training simulators, you can train them in a safe environment, test out new control strategies, and again, that snapshot feature I mentioned at the beginning, you can use that to set up training situations that might be difficult to set up. You can just start them up and go, rather than trying to set it up with all the right data and the right, so the controllers and the right execution part. So that's a nice feature. So maybe maybe you're not ready to do the jump to the digital twin. FactoryTalk Logix Echo can still be used as a standalone tool. And like I said, developing an HMI application without being directly connected to a physical controller, that's a pretty tough task. So certainly use it for HMI interactions, testing HMI interactions. I know I'll be trying it out with all the third-party HMI softwares as well. You can also test interactions between multiple controllers. Say you have a system with 2, 3, 4, whatever controllers, and there's a produce consumed tag data in between them, and you want to test that out. That this is a perfect tool for doing that. And then emulating the different Logix controllers, you do have access to try them all. The P controllers included. You could try those plant PAX process objects, see how they execute, see how they might interface with an HMI, and that might be what you need to see before you can verify it in your system, and you don't have to go out and buy all the hardware to do it. And then different firmware, as more and more firmwares come out, you can maybe check the function of each firmware, see how it interacts, because you can assign each firmware to a different controller and try that out. And that's all I had. Hopefully that made sense.
All right. Thanks, everyone. Thanks for taking time out of your day and joining us. Have a great day.